Good afternoon, children. We are discussing the problems based on first chapter, that is matter in our surroundings. Yesterday we discussed 20 problems, and the last problem which was discussed, it was why is ice at 273 Kelvin more effective in cooling than water at the same temperature. Both the things, that is ice and water, both are at the same temperature, children, but why ice will give more cooling effect and water, though it is at the same temperature. 273 Kelvin means 0 degree Celsius. 0 degree Celsius means it is very cool water, cold water you can say, and it has turned into ice also. Now you have to give the answer that why that ice is also at the same temperature, that is 0 degree Celsius, and water is also at the 0 degree. But why this ice gives more of the cooling effect? What is ice? Ice is solid, and what is water? Water is liquid. So liquid has changed into solid. This is what? For changing from liquid to solid state, what has happened? The particles, they have come closer, and in this coming closer, what happens? They have taken, means they are less, and they have lost their energy. That is, energy is, this is condensation, this is freezing. So what has happened? That they have lost their energy, so they will have less of heat energy. Molecules, particles, they are coming together, they are coming closer to form the solid, and therefore they will give more of the cooling effect. They will have less of heat energy, so they will give the more of the this cooling effect, right? Now let us discuss in your study material problem number 21. What produces more severe burns, boiling water or steam? What produces more severe burns, boiling water and steam? Just now we have discussed about water at 0 degree and ice at 0 degree. So here what has happened? Ice is giving more cooling effect. Latent heat we have done, children. So don't think over that what may be the answer. You know everything. Latent heat of fusion, latent heat of vaporization. In the previous case, that is ice 1. Latent heat of fusion, and in this case latent heat of vaporization. What is boiling water? Water is at 100 degree, steam is also at 100 degree. We know that till all the water it changes into steam, the temperature remains the same, and that is heat of vaporization, right? And that is latent heat. Latent heat of vaporization, that is hidden. You cannot see that change in temperature in the thermometer. Thermometer shows the constant temperature, right? So here boiling water is at 100 degree, steam is also at 100 degree. This is liquid and this is gaseous. Now this liquid, in case of liquid, the particles, they are this much placed, at this much distance placed, and in case of gases, the particles, they are very far away. So here liquid state has changed into gaseous state, and this heat which you cannot see, change in temperature which you cannot see on thermometer, that heat is being utilized in moving apart these particles, right? So this is having more of a heat energy, this is having less of heat energy. Obviously if you get a burn with steam, then this is having more of heat energy, so it will give more heat to the skin, and therefore the burning will be severe. If a person gets burning by steam, then burning will be severe. Here it is liquid, so it is having the temperature, though it is same, but here the heat which we are giving, it is being utilized in moving apart the particles, changing from liquid to gaseous state, and therefore it is having more of heat. And if a person gets burned by steam, then it will give severe burning, right. So, this is about the problem number 20. Then come to, this is problem number 21, sorry children. Then this is, next is 22 problem in your study material. Name A, B, C, D, E and F in the following diagram showing change in its state. All these we have taken from your NCERT book, children, right. So, if you have any confusion, then see your NCERT book and you will get the same problems, and solution and discussion, explanation I am giving you. So, here this is the diagram. This is solid, this is liquid, this is gas. Here what we are doing here is increase heat and decrease pressure. You are increasing the temperature and decreasing the pressure. Here what you are doing is decrease heat and increase pressure. Clear? Now you have to name A, B, C, D, E and F. Clear to you, children? Name A, B, C, D, E and F in the following diagram showing change in its state. Here solid is changing into liquid, liquid is changing into gas. Now you are increasing heat and therefore you are increasing temperature, and therefore this solid is changing into liquid, and you are decreasing pressure. You are releasing pressure. So, solid is changing into liquid. So, what this A will be called as? Then B, then C. Changing of solid into liquid. What change is this? This is vaporization. Is it vaporization? Changing of liquid into gas is vaporization. And this is what? Changing of solid into liquid. This is melting. This is melting. Then changing of this liquid into gas by increasing of the temperature and decreasing the pressure. This will be what? This will be vaporization. Then changing of gas into liquid, that is C, by what? Decreasing temperature and increasing pressure. Changing of gaseous state into liquid state, this is what? Condensation. Condensation. Then changing of liquid into solid by decreasing heat or lowering the temperature. This is what? Freezing or fusion. Changing of liquid into solid. Now come to F, children. Solid directly changing into gas without changing into liquid state. This is what? Sublimation. Right? This is what? Sublimation. So, this is about the problem number 22. Now, come to the problem number 23, children. Problem number 23 in your study material. When a small amount of common salt is added to water taken in a graduated cylinder, there is no detectable change in the level of water. Why is it so? This is a graduated cylinder and here are the graduations. This is water in it. This is water in it. And to this water I am adding common salt. I am adding common salt. But whatever was the level of water, it remains the same. No change in water level. Explain why is it so. As we know that in liquid the molecules, they are far away, not very close you can say, and not very far away, but in between there are spaces left, and these are called as voids or spaces. So, whatever amount of common salt I have added, then this place which is vacant here, the common salt particles, they will come in between. Common salt particles, they will come in between. And why it happens so? What is asked? Why is it so? Because there are present, this water is liquid and particles, they are far away, not very far away but little far away. In between the particles there are empty spaces which are called as voids, and common salt particles, they take the place in between these particles of water, and therefore there is no increase in the volume or increase in the level of the graduated cylinder. Whatever graduation was shown here, the same will remain after adding common salt also, right. Then next questions, that is question number 24. Question number 24. Solids have a regular shape whereas liquids do not. Explain. We know that solids have fixed shape, regular shape, they are having defined shape. But this liquids, they take the shape of the container. What is the reason? The reason being the same, that particles in solids particles are very close, or you can say that solids, they have lattice. What is lattice? It is a particular type of, you can say, the arrangement. Particles, they are arranged in a discipline or in a defined manner, and that gives a particular shape to the solid. But in case of liquid, particles are far away and therefore what happens? They take there is no fixed shape, but they take the shape of the container. Liquids take the shape of container. The next problem of your study material, children, that is, what are fluids? What are fluids? You have to explain. Again, see children, the marks of the question. If it is having 1 mark, just you can say explain in 1 or 2 sentences. If it is same question is having 2 marks, then explain in detail with example. And if it is for 3 marks, then give 2 or 3 or 4 examples and explain it in detail, very detailed, right? So, what are fluids? Explain. Fluids means the property of flowing. Can solid flow? No. Liquids can flow, and of course gases also flow, right? So, fluidity is the property by the virtue of which you can say that the liquids and gases, they can flow. The reason being that the particles, they are far away, in gases they are very far away. So, there is no there is less force of attraction in case of liquid, and very little force of attraction in between the particles in case of gases, and therefore they can easily flow. Then next question, that is 26th question of your study material. What are condensed phases of matter and why are they called so? Condensed phases of matter and why they are called so. Condensation. What is condensation, children? You have studied already. What is condensation? If we heat anything, you can say liquid or you can say water, then it changes into gaseous, that is water vapor. And now if this water vapor I cool down, then what happens? It gets condensed, that is process of condensation. It gets condensed into liquid, and liquid it changes into solid. So, condensed phases of matter are liquid and solids, and why they are called? Because they are the particles, they are very close to each other and they cannot flow, therefore they are called as condensed phases. Then question number 27. What is the difference between fluidity and viscosity? What is the difference between fluidity and viscosity? Just take the example of water, children, or milk. Here you take the example of honey. These are thin liquids, and this is thick liquid. Thick liquid means density is higher, and if density is higher, it can flow with difficulty. It resists the motion, it resists the flow. So, fluidity means it can flow easily, but viscosity means it gives resistance to the flow, just opposite of fluidity. So, honey, it is a thick liquid, it is a heavy liquid having higher density. If you will try to flow it, then of course it will flow. It means if you are taking out honey from the bottle, then it comes out, but it takes some time. It's the same thing if you take in this water, you take in bottle and you just put like this, then you just keep it like this, then all the water comes down. So, this is about the viscosity and this is fluidity. Then next problem, next question of your study material, children, that is question number 28. Both sand and water take the shape of vessel in which they are placed, yet sand is called a solid while water is called a liquid. See, children, you are not asked directly what is solid, what is liquid, what is gas, but based on these properties, based on the definition of this, based on the structure of these, you are asked indirect question that sand is also a sand is solid and water is liquid. But if we keep sand in a glass, then it takes the shape of glass. Here this is the glass and here are the sand particles. They are taking the shape of, and this is water. These are sand particles and this is water. This is liquid, this is solid. Both are taking the shape of glass, but here we are calling this as solid and this we are calling as liquid. Why? What is the reason? Here sand particles itself, they do not change the shape. They are very small, so you are putting them in a glass, but itself they do not change the shape. So, they are called solid, but whatever liquid we are putting here, it takes the shape of glass, it changes the shape and therefore, it is called as liquid. Sand particles are very small, so small that they cannot, so small that they can be put in a glass or in a container or in a beaker and they take the shape of the container, but itself they do not change the shape, right. Then question number 29, children, of your study material. Which will have more density, 1 gram of cotton or 1 gram of iron? You are given 1 gram of cotton and 1 gram of iron. Obviously, very common sense we have that cotton will be having less density and iron will be having more density. This will have less density and this will have more density. But how you will explain, children? If the question is of 1 mark, then you can directly write that this will be denser, this will have more density, this will have less density. But if it is of 2 marks or 3 marks, then what you will do? You will have to explain it that D is equal to M upon V. Here M is same in both the cases. We are taking 1 gram, whether it is cotton or it is iron. But here this is more, volume is more, and this volume is less in case of iron. 1 gram of iron will have this much of volume and 1 gram of cotton will have this much of volume. So, this is more here and this is less here. So, obviously, if this is more, volume is more, density will be less, and here because volume is less, so density will be more. So, you have to explain it. Again, it depends upon the marks, how many marks that question is carrying. Next question, that is question number 30.